In this example, we're going to go ahead and verify this trigonometric identity. And for this identity, it says that the secant of x minus the cosine of x equals the sine of x times the tangent of x. So you'll notice on the left side we have this difference, and on the right side we have this product right here. So basically we need to choose one side from which to work, and we need to make that side look like the other side. So probably it's going to be easiest to work with the subtraction side, so we're going to manipulate this left side into looking like the right side. Okay, so secant x minus cosine x. Well, I think the best thing to do to start with is to go ahead and take this secant x and make him 1 over cosine x, so both of these terms on the left side are in cosine. So let's go ahead and do that, and it looks like 1 over cosine x minus cosine x over 1 equals, and then of course we have that right side. Okay, so from here, let's go ahead and get common denominators since we're subtracting these two fractions. And the fraction on the right is over 1, so it looks like we're going to multiply by cosine over cosine. So times cosine x times cosine x. So we'll end up with 1 minus cosine squared x over that common denominator of cosine x, and of course equals, and this whole right side it's understood that it kind of just comes along for the ride. So we know that 1 minus cosine squared x is going to be sine squared x because we can use a Pythagorean identity for that. I'll go ahead and write that down. We know that sine squared x plus cosine squared x equals 1. Which means if we subtract cosine squared x from both sides, we see that sine squared x equals 1 minus cosine squared x. So in the numerator, we have that 1 minus cosine squared x. Let's go ahead and replace it with this sine squared x. So sine squared x over cosine x equals, and again, still, we're trying to make it look like this sine x times tangent x, so we're making it look like a product, and it looks like we're just about there. Let's go ahead and take this sine squared x and split them up as a sine x times a sine x, and put that over that common denominator that we had before of cosine x. So let's see if we can squeeze it all in here. Okay, so we're trying to make it look like sine x times tangent x. And remember that tangent x can be rewritten as the sine of x divided by the cosine of x. So if I were to take this fraction, split them up, I have a sine x right here, and then I have a sine x divided by cosine x right here. So I could rewrite that then as sine x times tangent x. And now that we have the sine x times the tangent of x on the left side, and that's what we were shooting for on the right side, we are good to go. So we're done verifying this trigonometric identity. So let's go ahead and look one more time quickly at the steps we took. We started by changing the secant x into 1 over cosine x. Then we got common denominators for these two fractions that we were subtracting. We went ahead and used a Pythagorean identity to exchange the 1 minus cosine squared x for a sine squared x. We went ahead and split this sine squared x into sine x times sine x, recognizing that this sine x over cosine x is our tangent that we were going for. So there we are for that trigonometric identity.